Okay, so section 4.4 is actually two really big topics. So we divide it in half. So the first 4.4 we're going to do is all about the Pythagorean theorem. Okay. You can see on the board we're going to stop and review, and then we're going to take a quiz Thursday. So you won't have any homework over the weekend. When you come back after your 3-day weekend, we will do 4.4 again, but this time it'll be the distance formula. Okay? So the Pythagorean theorem only works for right triangles. So if you have a right triangle like the one you see on the board, you know that it's a triangle with one right angle, right? There are special parts to the right triangle. The two sides that make the right angle, those are called the legs. The legs are always the shorter two sides. You'll also have the hypotenuse. The hypotenuse is the side that's opposite the right angle. That one's always the longest one. You have to be able to distinguish if it's a leg or hypotenuse, or you'll set up the whole thing wrong. So we got to make sure that we're using the smaller two as the legs. We call those the A and the B. And then the C is always the hypotenuse. That's our longest side. So for number 1, we are just practicing labeling these. So which two sides are the legs? Y Z. And Z. Good. And then the hypotenuse, always start at the right angle and just shoot out across X. Good. Once again, if you don't know this part, you will not be able to do the rest of the lesson. You have to first be able to identify what are the legs. Those are the A and the B in the Pythagorean theorem, and the hypotenuse has to go in as the C. So the Pythagorean theorem is used to find the missing side of a right triangle. The Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. It's usually written like this: a squared plus b squared equals c squared. Where a and b are the legs. Those are the smaller two sides. And c is the hypotenuse. All right, so we have to start by deciding what goes where.
Leg plus leg equal hypotenuse.
So which ones are the legs here?
A and B.
The A and the 6. Good. So I'm going to do a squared plus 6 squared equals 10 squared. If you flip-flop them like the 10 and the 6, you are absolutely going to get the wrong answer. Okay? So don't do that. Make sure the longest one goes in for your C in a squared plus b squared equals c squared. The hypotenuse needs to be by itself. All right, now you actually square them. So a squared plus 6 squared is 36. 10 squared is 100. Minus 36 from both sides. All right, and what is the square root of 64? 8. Good. Now, notice the directions say round to the nearest tenth if necessary. You need to make sure you're following directions on these. Sometimes it says leave your answer exact. That's when you do a factor tree like we practiced yesterday. If it says round, that's when you can just type it into your calculator, round to the nearest whatever. In this case, it's tenth, so it's one number after the decimal point. So make sure you're reading the directions to know what form to put it in. Questions? Here is number 2. What was your question?
Does it matter, like we put this?
No, that's a good question. So the 6 and the A can go either way. Addition's commutative, so that one's good. The important one is the hypotenuse. All right, what are my legs? 8 and 7. So make sure the 8 and the 7 are on your left side. Equals, this time we're looking for the hypotenuse. We're looking for the C. All right, so square 8, what do you get? Square 7, what do you get? 49. Square root of 113. Anyone have a calculator handy?
What you need to do?
It's like,
It's like 10 and a half.
10.6.
no!
So number 4, what am I looking at?
What you gonna write down?
You tell me what to write down. 7 squared. Where'd you get a 7?
49.
Square root of 49, right?
I don't think we do that yet, right?
B squared plus the square root.
Oh, I see what you did there. Yes, actually. So he saw that the square root of 49 is a perfect square, right?
Yeah.
So you can make it 7 and then square that, and what would you get? 49. Or the way that I did it is I just plugged in the square root of 49, and then the square root and the squared already undo each other. So it kind of depends if you noticed that it was a perfect square or not. Yeah, that's an interesting one. So either way, your second line should look like that. If you made it a 7 and then squared the 7, or if you just canceled out the square root and the squared, either way, you get b squared plus 49 equals 196. Then what? Subtract 49 from both sides. Now what? Square root it. 12.1. Very good. Questions? How will I set this one up? 20 squared plus 21 squared equals c squared. Getting a little chatty. What is 20 squared? 20 squared, 400. Someone said 40. All right, 21 squared is 441. When you add those together, you get 841. And what's the square root of 841? 29. What are your questions? So, a Pythagorean triple is a set of 3 positive integers, a, b, and c, that satisfy the Pythagorean theorem. Basically, that's 3 whole numbers that work. So like the one we just had, those are all whole numbers, right? That was a Pythagorean triple. The first example we did, those all ended up being whole numbers. That was a version of a Pythagorean triple. It was a multiple of one of them. But basically, they are special numbers that work in the Pythagorean theorem. Here are 5 very popular ones, okay? So 3, 4, and 5 will work. 3 squared plus 4 squared equals 5 squared. 5, 12, 13, 8, 15, 17, 7, 24, 25, and 20, 21, 29. The cool thing is that, let's just take the first one, for example. This is probably the most popular one. If you multiply these all by 2, those numbers work as well. Like 6, 8, and 10 works. 9, 12, and 15 works. 15, 20, and 25 works. So, I don't know if I necessarily memorize these, but they're kind of good to have on your radar, especially the first couple that appear often. All right, so our last example for today says, find the length of the hypotenuse. Tell whether the sides form a Pythagorean triple. So how am I going to find the length of the hypotenuse?
8 squared plus 15.
Yep, 8 squared plus 15 squared equals c squared. Same old Pythagorean theorem we've been doing. Now, if our answer is a whole number, then it's a Pythagorean triple. If our answer is a decimal, it's not a Pythagorean triple. 8 squared is 64. 15 squared is 225. C squared is C squared. Now, I'm going to back us up for just a second. Do you see this?
Yes.
So, is it going to be a Pythagorean triple?
Yeah, no.
It is. Here's why. Here's the math. But if you memorize the Pythagorean triples, you'll start to notice them. You'll start to see them a lot. You won't necessarily have to use the Pythagorean theorem. If one side's 8 and one side's 15, and they're the legs, the hypotenuse will always be 17. Okay? You don't have. That's what I'm saying. You don't have to, but if you do, there.
Mr. Patterson gave us a chart.
Oh, I'm not giving you a chart, but I'm. All right. Shh. So what I was saying, if you have these in your memory, you don't need to use the Pythagorean theorem. If you know it's a Pythagorean triple like 3, 4, 5, and I'm asking you for the hypotenuse, you can just tell me it's a 5. If you don't memorize them or if you forget, you can always do the Pythagorean theorem. It's easy enough, especially with whole numbers, you'll be fine. Any questions?